Hi class, in this video we're going to talk about plotting in MATLAB. Graphics and graphic communication of ideas is very critical for engineering. In fact, many scientific articles are summed up by one or two good graphs, and graphing is an easy way to visualize complex data. MATLAB provides a lot of built-in functions to provide you with easy ways to visualize data using plotting, including plots, 3D plots, uh, geoplots, polar plots, contour plots, surface plots, and images. So MATLAB has a lot of built-in functions that can help you visualize your 3D data. We won't cover all of them in this video, but I encourage you to go to MATLAB's documentation to see how you can use these functions in order to generate plots. To understand how plotting works in MATLAB, let's take a look at their basic line plotting function. The function is called plot, and it has several inputs that you can give it. If you give it just x and y, that creates a 2D line plot, and what it does is will linearly interpolate in between points. So I'll show you what that means. If x and y are both vectors, they must be of the matching length, and the function will plot y versus x. So it'll plot whatever you give as the first input as the horizontal axis, and whatever you give as the second input as the vertical axes. If x and y are both matrices, this is less common, they also must be equal size, and it'll plot the columns of y versus the columns of x. These other cases are less useful, but you can use them as well. So let's take a look at this in MATLAB to see how we could make this work. So I've written a script here in MATLAB. The first thing I did was clear any variables by using clear all, or you could use clear vars to clear the variables in the workspace. And then this is a new thing right here, CLF clears any current figures that you have. So this will clear any figures. And that's important. If you already have a figure up, you may want to clear what's already in there to make a new figure. This function here, figure and input 1, tells MATLAB that any plotting function that comes next will be put under figure 1. So we can have multiple figures in a MATLAB workspace at a time. So the very first thing I'm going to do in terms of creating a variable is assign to the variable x1 linspace 0 to pi to 10. And so we know that linspace will create evenly spaced points between 0 and 2 times pi, and this third value will make it so it's 10 points. Remember, if there was not a third value here, it would default to 100. And then y1 will be equal to sine of x. And since we know that x1 should be a 1 by 10 vector, then y1 will also be a 1 by 10. And then when we use the plot function, we'll pass in x1 as the things to plot on the horizontal axis and y1 as the things to plot on the vertical axis. So let's go ahead and run this section. And what you see here is I've created now a figure, but it doesn't look exactly like your typical sine function. And that's because what MATLAB has done, let's take a look at our workspace. So if you look at our workspace, what MATLAB has done is create, and this size here was a 1 by 10 and a 1 by 10. So there's actually 10 points here. And in between those points, it's just drawn a straight line. That's because MATLAB doesn't know that this function is a sine function. All it's doing is plotting the points x and y. So this would be x1, y1, x2, y2, these data points, and then drawing a straight line in between them. So MATLAB plot function will just plot a data points in between, and it defaults to putting a straight line in between those points. So it's important to understand that it's not plotting sine the function. What MATLAB is doing is plotting lines in between those. So how can we make this look a little bit more like a sine function? So let's make a plot again, but in this time, we're going to put this plot under figure 2. So we'll create a second figure. And then we're going to create new variables x2 and y2. And for this time, we'll make 100 points. So we could actually drop this 100 off. It'll default to that, but I'm just making this here so you can explicitly see that this will create a 1 by 100. And since we're passing a 1 by 100 to sine of x2, y2 will also be a 1 by 100. And then we'll plot x2 versus y2. So let's go ahead and run this section. And what you'll see, we have now figure 2, and we actually have two figures. So let's take a look at MATLAB's two figures side by side. So what you see is that this one actually looks a lot more like a sine function. And that's because there's 100 data points between 0 and 2 pi. But it actually, if you were to zoom in on any one section here, and actually I guess it starts to look more like a line. That's because we're going in between a bunch of data points that we can zoom out to our graph. So we've essentially just refined this. It's still not plotting sine the function, it's just plotting the x and y data points. But now this looks a lot more like a sine function as you know it. So if you give the plot function more than one data set, such as x1, y1, and x2, y2, then it'll plot both of those data sets on the same figure. So let's go ahead and do that in MATLAB. So we can re-look at that function, and now we've already got x1 and y1, x2 and y2, and if we plot both of those things at the same time, let's go ahead and see what happens. So now what it did is it plotted both of those on the same graph. So when generating a plot, if you were to plot to a figure, such as we're doing here, so let's say, go ahead and run this section, and we've plotted the figure for our plot of x1 and y1. However, if you call the plot function again, what this will do is it'll plot it to any current figure that is the active figure. And in this case, the last figure we set to be active was figure 4. What this means is that it will overwrite. So let's run this section. So if we go ahead and run this section, what you'll see is under figure 4, now we have that smooth plot. And that's because it overwrote the plot that we had previously done. So if you do plot and then you want to replot on the figure, what you could do is, like we did before, was call all those things you'd like to plot in one time. Another thing that you can do is use the hold and then on. And so let's go ahead and redo this. So if we run this section, it's going to plot this jaggedy plot for our sine function. And if you use the hold on functionality, what that does is it keeps any plots that are currently on figure 4 and then plots this next plot function on top of it. So if we run this section, what you'll see is this time you'll get both figures there. But if you don't do the hold on and you run the plot again, it'll overwrite what was currently there. So there's two ways to achieve this. One is to just add all the things you'd like to plot in one plot function call, or use the hold on. And if you'd like for future code to overwrite anything, like after this, I'd like it to redo it, you can do hold off. And then if I go ahead and make another plot of x1 comma y1, what this will do is now it will overwrite it. And so there it overrides the figure. So if you give a third entry that is not a vector or an array of data, but that is a line specification, you can set the style and marker and color for the line that you're plotting. So let's take a look at this line specification. And so there are three things that we can specify. That is the line style, the marker, and the color. And the way that you should do it is in that order. So the style, marker, and then color. If only one of them is specified, then it'll only change the one thing. So you could only specify color and then it'll use the default line style And by default, there is no line marker. So some line style options that you have are just the solid line. That is the default. So you don't actually ever need to specify that. That's just specified with a dash. 2 dashes are given as the dashed line, and then a dot dash is a dash line, and the colon operator actually here is a dotted line. One thing that's important is that any line specification must be in between, it must be given as a string, so in between apostrophes. The markers, you have several choices from circle to a pentagon. So you can look under line specification to get a different marker that you like. Two I like are the circle and then the cross. And for color, you have several color options that can be controlled by line spec, but there are more than this, but line spec can only control these standard ones, and I'll go into how you can get more colors than this later. But you have Y for yellow, M for magenta, R for red, and then black is K because blue is B. So let's take a look at how we could do this in MATLAB. So let's take a look at using line specification for MATLAB and the plotting function. So what we're going to do here is on figure 1, we're going to plot t, and t is a vector starting from 0 to 2 pi, and we're going to step by pi over 20. And so what we'll do is plot t versus sine t, and then to not overwrite that, we'll use the hold on function here. And then we'll plot t, and then the y-axis will be sine of t minus pi over 4. So we're doing a phase shift here. We'll also plot t versus sine of t minus pi over 2, and versus sine of t minus pi. The third entry over here is our line specification, and MATLAB recognizes this string as a line specification. It turns out it doesn't matter the order that we give it, but it does recognize the characters in the string. So this dash and a dot, MATLAB will recognize as a dashed dot line. The R, MATLAB recognizes as the color that it would like, or that we are requesting this to be plotted in, and that is red. And the asterisk will be the line marker for the data points. So it'll mark the data points with the asterisk. The dash is the dashed line, M is magenta, and O will be a circle marker for the data points. And then B, MATLAB recognizes as blue, and S as the square marker. Since we did not provide a line and we provided a data marker, what MATLAB will do is actually have no line. So if you provide a data marker and no line specification, MATLAB will do it as no line. If you provide a color and no line or marker specification, MATLAB will do no marker, but it will do the default line in between the data points. So let's go ahead and plot this. And what you'll see is it cleared the figure that we had previously, and now it plotted those. So here are all the plots that we just generated by manipulating the line specification. So if you want more options than the standard line specifications, you can also give other arguments to specify more finely how your line and data points look. So one thing is you can actually use RGB triplets in order to specify the line color. So if you want other things, you can just give an array with R, G, and B values. And by giving any value from 0 to 1, so white would be 1, 1, 1, and we'll learn more about RGB later, and black is 0, 0, 0, but any color can be had by using different values between 0 and 1. So if you give this as an argument, what it would do is give you a different color. So blue could be given by 0, 0, 1 as that array for an RGB value. Additionally, you can specify line width. So if you give the string line, and it's important that you have it as actual the case sensitive, so line width, then you can follow that with, say, 0.75 or 1. So 0.5 is the default, but if you'd like your line to be thicker, you can make it 1. Okay, you can also get the markers to have edge colors, so you can have marker edge color, and there's plenty of options that you can have to specify. You can specify the marker face color, so if you need more control, go into the name pair value arguments, and so what you could do is, for example, color, and then following color would be the array, or for example, we talked about the line style or line width, and following that would be the thickness. So there's many options, and I'll give you a quick example of how we could use this to make our plot look a little nicer. So in figure 6, what we're going to do is plot x versus y, but along with setting the common line spec thing, so this is a dashed green line with a square marker, we're also going to specify the line width. So normally it's 0.5, but we're going to make it thicker to be 2. We're going to style the marker size to be a lot bigger, 10. So we're going to have very large markers. We're going to also give the marker edge a different color. That's going to be blue. And then the face color, what we're going to give is this RGB value of 0.5, 0.5, 0.5 to have this a non-standard color. Okay, so let's go ahead and run this section. And what you see here now is we've gotten our line that is very different than the standard line by specifying the line specifications and then the line pair arguments such as line width or marker size. So up until this point, we've just talked about creating a plot of x versus y, but this is not a very good readable figure because we haven't labeled the axes or given a title for what this graph is. And if we had multiple plots on the same figure, you'd want a legend. So we can specify that in MATLAB by using the x label, y label, title, and legend functions. So here we're passing in an argument of a string, and it'll put the x string on our x-axis. We're labeling it x, but we may want to be a little bit more descriptive in what you're actually doing, such as give the units or maybe something a little bit more descriptive that maybe is x position or time. And then we have the y label here. We're using the y label function, and you also pass in a string. And same thing here for title, we're passing in a string. Now, one thing that you could do is you can use these curly braces, and what this represents is a superscript. So instead of doing x caret 2, which you may recognize as being x squared, but it looks a lot nicer if it's just a superscript. You can also do a subscript by doing an underscore. So if you would have done underscore, this would be x superscript or subscript 2. So the underscore followed by the curly braces would give you a subscript. But we'll do superscript here because this is a plot of x squared and x cubed. Now, an important thing to know here is x is a vector. It's 1 by 10. And so you need to make sure you're using the dot squared operator. If you exponentiated this without this dot, it would be matrix exponentiation, which would not be defined for a vector. So that would throw an error. Let's go ahead and plot this. So we see here is our plot. And now we've labeled the y and x axes, and we have a title for our figure as well as a legend. And you can specify more things such as the font, color size, and for the title as well as the x-axis, and as well as for your legend. You can also specify the placement of the legend. So I'd encourage you to look up x label, y label, title, and legend under MATLAB's help to see how you can further manipulate these functions.